Hello, my name is Tyler Pratt, and this is my LabVIEW project for engineering programming at Oregon Tech. Here in LabVIEW, I have interfaced a function generator with an oscilloscope on my front panel with two images that I imported to my front panel. I'll begin by explaining my function generator. Here on the display, it tells me my frequency and the amplitude of my signal. And my primary dial here for frequency allows me to adjust down to 1 Hertz all the way up to 20 kilohertz of a signal with this multiplier knob here. I've also got the ability to change the signal type. I can have a DC signal in which I need to turn off my trigger to view, otherwise it won't trigger. I've also got a typical sine signal, a square, sawtooth, and a triangle. With all of these, I can change the offset of the signal, or I can also change the amplitude of the signal from 0 all the way up to 10 volts. You'll get a better idea of that once I show you the oscilloscope. Let's see, I've also got the ability to add a uniform noise to the signal, which I can change the amplitude of here with this dial. You can see at a low amplitude I'm going to have that noise is going to be more visible on my signal, and I can adjust that noise up to 1 volt of noise or down to essentially 0. I can change this to Gaussian white noise, which I control here by changing the standard deviation of the signal. Simple enough. That's a lot of noise. I'm going to go ahead and turn the noise off for the minute and go back to a sine wave, something we're more familiar with. Up here on my oscilloscope, maybe I'll start by changing this purple color here with this color legend, because some of you are probably thinking that's hideous. That's fine. Here I've got a cursor legend I've got two cursors here, cursor 0 and cursor 1. The cursor legend tells me the values of this cross-section of the cursors, and this is helpful for such things as verifying the amplitude, the period of the frequency, etc. However, there's not a whole lot of need for that, because here I've added the indicators for the length of the period, the root mean squared value of the signal, the mean, the min, max, and the peak-to-peak voltage. Here with this volts per division knob, you can see I can adjust it all the way up to 5 volts per division for larger signals, or I can adjust it all the way down to 0.1 volt per division for smaller signals. See, if I turn down my amplitude here, you'd be able to see that. And I'm going to go ahead and let me turn off those cursors and get this back to a decent value there for showing you my milliseconds per division button. This allows me to see, my lowest, full period of my lowest signals all the way up to, to my highest signal. Actually, my highest signal here, would be, I would show it at this setting here. Of the 0.1 millisecond per division. Let's see, get this back in a decent range there for instruction purposes. This timer here tells me how long this presentation's been going, of which I'm sure is getting lengthy by now, but I can reset that at any time, buy myself some time. This button here allows me to save the signal, and I've made it ask me for the name of this signal so I can keep track of it. I can also change the intensity here of my signal with this dial here up to 5, and the line styles. Let's see, last but not least, the fast Fourier transform value of this signal. I've got 3 types of analysis here, from the Hanning, the Hamming, and the Blackman. This top graph tells me the magnitude as a function of the frequency, and this lower graph here shows me the phase in degrees as a function of the frequency. And I do believe that's about it. I'm going to turn off my saved signal file, and I should find a text file in that folder. Reset my time once again, so buy myself some time, and I think that's about it. Thanks for your attention.